All right. One of the most difficult things I think with this chapter is keeping straight the idea of adding and subtracting and keeping it separate from multiplying, because there's going to be a lot of things that are done differently, but there's also going to be a lot of similarities between the two, and keeping that straight is going to be one of the most difficult parts of this. When we are multiplying radicals, we multiply radicals that have the same index. Okay? So, unlike adding and subtracting, the radicand does not matter here. Okay? So, what does matter is that whatever I have under the radical, what does matter is the fact that the index, or the number attached to the sign right here, that is the same. So if I had something that looked like this, where my index was 2 in both of these locations, I could multiply these together. However, if I had something that looked like this, where I have two different values, and that's supposed to be a 3, if I have two different values as my index, I would not be able to multiply these. That would be as simplified as that could get. But you're not going to approach any problems that have different indexes. I just want you to be aware that that's a rule that we have with radicals. There are 3 basic steps to multiplying radicals. Okay. The first one is to multiply the coefficients. The second step is to multiply the radicands. So essentially when I'm talking about coefficients, I'm talking about the outside of the radical. And when I'm talking about the radicands, I'm talking about the inside of the radical. So the coefficients can be multiplied with the coefficients. The radicands can be multiplied with radicands. And then step 3 is to simplify. This is another difference between multiplication and addition, because in addition we would have simplified first and then added. With multiplication we multiply and then we simplify. So, example 1. Okay? If I do not have a coefficient out in front of my radical, then that coefficient would be a 1. Okay? 1 does not have to be written, so I have a 1 in front of both of these, so 1 times 1 would give me 1. You don't have to write the 1. You can if you want to. But then we're going to come over here to the radicands. So I'm going to multiply the radicands together, and I get 9. Okay, so I've multiplied the outsides, multiplied the insides. Now I have to simplify the radical. So, does the square root of 9 simplify?
Yes. To 3.
Okay. That's your final answer. I want to present this in a different way for you, because it's going to show up in a couple different ways. I can write this slightly differently. I can write this like this. And at the very beginning, when we talked about radicals, we've talked about how the exponents get rid of radicals and radicals get rid of exponents. So when I have these two showing up together, essentially one's erasing the other, and you're just left with the number that's underneath the radical sign. So either way you look at this, you're still going to get an answer of 3. Number 2, okay? Multiply the coefficients. So my coefficients are 2 and 4, which gives us 8. And now we're going to multiply our radicands, 12 and 15. That gives me 180. And then step 3 is to simplify. So what are some numbers that multiply to get 180?
90 and 2.
18 and 10. 9 and 2.
Wait, that's 18.
I don't know.
9 and 20.
Remember, I always start with 1 and I work my way up. So 1, 2, does 3 go in there?
Yes.
3 and 60. How about 4?
Yes. 45.
5.
9 and 20.
36.
Okay, this is where I would stop. Okay? Yes, we have several other factors. We have 10 and 18. We have a whole bunch that we can go through. We 9 and 20. But by doing it from the bottom up with the smallest numbers are going to match up with the largest number. The next smallest is going to match up with the next largest. So if I work from small up, that's going to find me the largest one on the other side. So once I find a perfect square on this side, I would stop. Okay? And if you're not sure whether or not this is your largest perfect square, look at the number it's being multiplied and think, what are the factors of that number? So if I have 36 and I'm not sure whether or not 5 is as simplified as it can get, I'm going to go through and say, what are the factors of 5? Well, 5's prime, so the only factors are 1 and 5, so then that would be my lowest amount. So I'm going to rewrite 180 as the square root of 36 times the square root of 5. 36 is going to simplify 6, but then I still have to remember that 8 that I got from multiplying my coefficients, so I'm going to bring it down, and then you're going to multiply your coefficients, so you would get 48 square root of 5. Okay, so outsides, then insides, then simplify. All right, next example. Okay. On these two problems, we're going to use methods of distribution. Okay. So I'm going to take the outside number multiplied by each term. So radicals can only be changed if it's multiplied by another radical. So 3 is a constant. It is not another radical, which means that the number or the radicand is not going to change. So when I multiply these together, you're just going to end up with 3 square root 3. Because you don't have another radicand that's going to change the radicand, and you don't have another coefficient that's going to change the coefficient, so we're just going to put them together. Now we need to do the square root of 3, square root of 6. Well, they're both under a radical, so they're going to influence each other. So I'm just going to multiply the numbers under the radicals together. Okay, so 3 and 6, that would give me 18. And then the sign in the middle there is a plus. Now I have to ask myself, do the radicals simplify? Well, that one doesn't. 3 is prime, so that one's good. Does 18 simplify?
Yes.
What are my factors that I'm going to use for 18? Okay, so I'm going to change this into the square root of 9. Square root of 2. If you are not sure whether or not that works, this is a perfect square. Can 2 break down any smaller?
Nope.
Okay, so I'm going to rewrite this. Square root of 9 is going to become a 3. Square root of 2 does not change.
Wait. Why is it turning into a 3?
Because I'm simplifying the square root of 9. So the square root of 9 would become 3.
Oh.
And then I'm just going to bring that 3 square root of 3 down. Can these two terms come together?
Nope.
Did these? No, because my radicals are not the same, so then that would be my final answer. Okay? Last but not least, when we are doing this type of a problem, which you'll see several of today, we're going to revisit an old friend of ours.
Oh my gosh.
I have friends.
No, you don't.
Probably not. I'm just kidding. No, me too, Haley.
All right, we are going to revisit the box method.
Oh my gosh.
Okay? This first set here has 2 terms, so I've created 2 columns. So I have 3 square root of 3. My second set here also has 2 terms. So I'm going to put one on one column and the other on the other column, making sure that you take the sign with it. So if it's negative, make sure that you've put that negative out front. So now when you get everything arranged, now you're just going to multiply. So 3 times 3, that would give you 9. 3 times square root of 3. 3 square root of 3. 3 negative 4 square root of 3.
Negative 12 squared.
Okay, that 3 is a coefficient, so all it's going to affect is the coefficient down here. That gets me negative 12 square root of 3. And then here I have a radical, which means the only thing that's going to be affected is the radical. So I end up with negative 4 square root of 9. Now I have to ask myself, in any of these situations, can my answer be simplified?
Yes. 9.
Okay, the square root of 9 can be simplified into a 3. So how is the negative 4 and the square root of 9, how are they bonded? How are they put together? Multiplication. So the 4 and the 3 are also going to be bonded by multiplication, giving me an answer here of negative 12. So now I'm going to go back and I'm going to say, looking at all of the terms that I've come up with by multiplying, are there any that are the same, that I can combine by addition or subtraction?
Full square roots of 3.
Okay, square roots of 3. So 3 square root of 3. Okay, so what would I get when I put those together?
Negative 9 square root of 3.
Okay, negative 9 square root of 3. Anything else that I can put together?
Wait, you.
Yes, you can put
Oh, wait.
9 and negative 12.
Oh wait, were you adding those?
Yes. Once you've done your multiplication, now you're combining by addition or subtraction. Okay?
Negative 3.
So negative, or 9 and negative 12, I put those together and you get
Negative 3.
negative 3. And that would be your final answer because we cannot combine those.
You would have to go